bottom line, with parabolas, you really need to be able to find maximums and minimums and be able to apply that. Like 68 in that particular situation, 80 inches is the answer to that one. You have to be able to find stuff using quadratics. So again, how do you find the maximum or minimum? What do you do?
Find the vertex.
How do you find the vertex?
B over 2a.
Yeah, negative b over 2a, and then you find the result by plugging in that value, and then you find the result.
Yep.
Okay, that's empty. That's great. Okay. Okay. So we are going to skip section 2.5. I'm just trying to do some things to kind of move us along a little bit, and 2.5 is just pretty skippable on the most part, and I think you guys will be pretty successful with 2.6, so we're just going to focus our efforts there. So here we go. Let's rock and roll through this, and we'll see what we can do. And again, I kind of sound like a broken record, but I think you've done this before. Using the given functions f and g to find f plus g, f minus g, f times g, and f divided by g. State the domain of each. Okay? Well, f plus g of x, what do we do with those functions? Add them up. So f of g and, well, first of all, function notation. You guys hopefully are comfortable with that. If I want f of 2, I plug 2 in, yada, yada, yada. F plus g of x, I'm just going to add these two things together. 4x squared plus 7x minus 12. That's f plus g of x. Those I think we can do in our heads very nice without showing any work. F minus g, on the other hand, that might be a little bit different for some of us. I don't know. So I'm going to go ahead and write this out. So I got 2x squared plus 4x minus 7 minus this whole thing. 2x squared plus 3x minus 5 equals, help me out.
Nothing x squared.
Nothing x squared. So no x squared is good.
Yep. What's that?
X and minus 2. Okay, how do we get that? Well, I have 4x minus 3. So that just gives me 1x. Negative 7, and these two negatives cancel, or I could distribute this through, and I see that I get a negative 2. So there's my f minus g of x. F times g of x, I would just take these two and multiply these out. Okay, not something that really seems like a lot of fun doing, but could you guys do it? If I asked you to multiply these two, could you do it? Yeah, I would take 2x squared times all three of these, right? 4x times all three of these. Negative 7 times all three of these, combine my like terms, and I'm done, right? Okay. Divided by f divided by g, neither. I wonder if these are going to factor. I think they are. I want to see. 7, 4, no, 7 and 1, no, that's not going to factor. We'll take it. We'll take some time and work on factoring one of these days. Yeah, so it's not really going to do us any good to factor. You'll just write one on top of the other. Okay. But here's something we need to consider. F divided by g of x is 2x squared. There's a reason why I factored that. Okay, let's talk about domains. Domain is what numbers can I plug in and have it work, have it make sense. On the most part, domains are always all real numbers. Okay. Hey, Miles, would you do me a favor?
Sir.
Can you fill this up for me? I'm kind of parched.
I got you.
I appreciate it. So on the most part, all real numbers, all real numbers, all real numbers. But what's the problem here on f divided by g? What am I going to run into when I have a fraction? It can't be 0. What can't be 0? The bottom can't be 0. The bottom can't be 0. So we've got to find what numbers make the bottom 0 and toss them out. Okay? I hope he doesn't fill that up in the toilet. Okay. Anyway. So this one, all these, the domains are all real numbers, all real numbers, all real numbers. But this one, x cannot be, what would make the bottom 0? Come on, I've already got it factored for you. 1 and negative 5/2. So I'm making a note that we cannot use either one of those. Okay? Nope. Can't do it. Can't do it. Okay. Thank you, sir. Appreciate it. Okay. I told them I was hoping you didn't fill it up in the toilet. Oh, he's got this grin on his face like maybe he did. Okay. Let's take a look at these one by one. Okay. Here's my two functions. Find f plus g of 3. There's two different ways you can do this. You could find f of 3 and g of 3 and add those together if you wanted. What's f of 3? Help me out. Come on. Wake up. 11. Okay, what's g of 3? 8. 11 plus 8. Last time I checked, it was 19. Now let's add these together. So f plus g, I could do it this way too. I could add them together first, x squared plus 3x plus 1. And then I could plug in 3. 3 squared plus 9 plus 1 gives me 19. Which way do you like better? Plugging it into each function first, or finding the rule and then plugging it into the rule? Second one? Okay. Matter of personal preference. I think the second one, if you had several to do, would make your life a little bit more efficient. Okay. Go for it. F times g of 4. Go. I don't care which way you do it. I don't know. One way is going to work better than the other one on this one. Remember, you can make your rule, or you can go f of 4 times g of 4. Oh, the calculators are clicking out now. Ugh. And I'm getting different answers. Oh, 3 times 4 cubed. Anybody got it yet? What do you get?
198.
198? I did it two ways and I got different answers either way. So I made a mistake on one of them, obviously. Let's see if I can figure out what it is. Okay, So I found my rule. 192 minus 16 plus 24 minus 2 gives me 198. On the top one, where did I screw up? Oh, 3 times 4 minus 1, so it should be 11. 198. Okay? So either way. Did you guys use the first way or the second way? First way? Okay. And I'm not even going to waste time with f divided by g of negative 1. I'm just showing that you can do it either way. But if you were doing multiple ones, I would probably even do the second one, maybe use a graphing calculator, and then go from there. Okay. I might wait on this one for another day, because that's going to take a little bit more time, and it'd be nice if everybody's here. Okay, this next one. Distance traveled by a ball rolling down a ramp is given by S of t is equal to 6t squared, where t is the time in seconds after the ball is released, and S of t is measured in feet. Evaluate the average velocity of the ball for each time interval. Okay, this is getting to stuff that I actually think is kind of interesting, and kind of getting to calculus basics, which is nice. Okay, so here's the thing. If I want to find the average velocity, all I'm doing is finding slope. So if I say evaluate the average velocity, your brain needs to think slope. Okay? It's a slope between 2 points. Well, our 2 points are 2 and wherever it was after 2 seconds, and 3 wherever it was after 3 seconds. Okay? So what we're going to do is we're going to plug in 2, and we get 24. I'm going to plug in 3 and get 54. And now I'm going to try and convince you why this is just slope. Okay? There's a reason why we hit slope so hard. It's used all the time in a lot of different situations. Okay? My slope here is 54 minus 24 over 3 minus 2. What does this mean? It started out at 24 at the start of my interval. It was 24 foot away. Now it's 54 foot. So how far has it traveled? 30 feet. In 1 second. So that is 30 feet per second. Okay? Now let's go to another smaller interval. 2 and 2.5. I'll do the first point, 2:24. Do the next point, 2.5. You tell me where it's at using your formula. Go for it. Keep your calculators out for a bit because you may need it. It's 38.25? No, 37.5? Okay. Okay. So now my average speed is measured in distance over time, which is what we're doing here. So my slope is 37.5 minus 24 over 2.5 minus 0.5, or minus 2, sorry. And I'm going to ask you to calculate this for me. 13.5 over 0.5, is that 27? 27 feet per second. So that is over a smaller interval. So what we're working on, if you take a look at my intervals, I'm getting closer and closer and closer to the speed at 2 seconds. I'm going to ask you to do the next one all on your own. Yes, sir. From this equation right here.
Which one's T?
The 2.5. Because this is the position after t seconds. So my input is t. So what we're doing is this is t, and this is my s, or which is my position. Okay? So same thing. I'll do the first one. 224. Go for it. I'll do this without a calculator, at least I'll try. No. What am I doing, Rex Road? Is it 26.46?
Yeah. that's what you get right there, yeah.
26.46, that's what I get for this point right here. Okay, good. And I'm just going to do this in my head. 26.46 minus 4 gives me 2.46 over 0.1, 24.6
Yep.
feet.
You know 2.1 squared in your head?
Yeah. Yep. It's just 21 squared. Back when I was in 8th grade, we had to memorize all the squares all the way up to 25.
I'll start one more time.
We had to memorize all the squares up to 25. So, in what? 8th grade. Yep. So, it just kind of stuck with me. Okay? Okay, let's make a prediction. Hold on, before you do this last one. I went from 30 feet per second over a 1 second interval. Now it's 27 feet per second. Now it's 24.6 feet per second. What do you think it might be over the shorter interval? 24? Let's try it. Go for it. Okay? Oh, I haven't even decided that yet. So this one I don't have memorized. Did you get something basically right at 24? Yeah. 24.006. So this is kind of, you don't realize it, but we're kind of sneaking in a calculus idea to you. Okay? Average speed from 2 to 3 seconds was 30. Average speed from 2 to 2.5 was 27. Average speed from 2 to 2.1 was 24.6. Average speed over that thousandth of a second, 24.006 feet per second. What do you think its instantaneous velocity was at 2 seconds? 24 feet per second in this case. Okay? So that is a very, very handy thing to have in your toolbox. There's no doubt about it. Okay? And again, I will wait on this. Kind of reminds me that lately, when you guys ever watch drag racing on TV at all? Okay. Where drag racing, what they do is they find out their speed at the end of the track. In 1,000 feet, which is like 300 meters around a track, the straight, the curve, the straight. But of course, drag racing, they do it straight. Okay. At the end of that 1,000 feet, now they're going over 340 miles an hour. It's nuts how fast they're going so quick. It is crazy.
So you used to drag race?
Yeah. Yep. Of course, we never went that fast.
Best you ever went?
158, I think, in a quarter mile. So it was fun. Okay. Let's go to the back. A composite function. Yeah, you got your Goff and your fog. You guys remember your Goff and your fog? Okay. So here's the thing. You have to get it back in your brain that G composed with f of x means we're going to do f first and then take that result, put it into G. Okay? That little circle means composed. It's weird we're doing the second one first and then putting it into the first one. Okay? And I'm going to do this a little bit different to make sure you understand the concept. Let's go down to this one right here. G of f of 2. If we wanted to do this the way where we're just doing one function and the other, what would we take and do with 2? Plug it into f, okay? So we would take and find f of 2 is 2 times 2 squared plus 3 times 2 plus 1 gives me 8 times 6. 8 plus 6 is 14. Plus 1 is 15, right? Yep. 15. So f of 2 is 15. We are not done yet. If I wanted to find g of f of 2, now we're only halfway there. So we took 2, put it into function f, got out 15. Now what do we got to do? Plug what into what? Plug 15 into g. Okay? So 15 into g. So in that particular case, for me, the pictures make a lot of sense. Okay? I'm going to take 2, plug it into f, it goes, gets me 15. Now I got to take 15, put it into g, it goes, and gives me negative 65. How do we get negative 65? Because g of 15 equals negative 4 times 15 minus 5. Negative 60 minus 5. Negative 65. Okay? But that's kind of the primitive way to do it. Here's what we could do. Is, you know what, I'm going to hold off even on this until everybody's here because this will be a great lead-in to what I'm doing on the other deal. But what we would do is we would take this and put that into function f every place we see an x. You know what would be kind of mean? Is if when the girls come back that whatever you guys say to a question is right, and then they'd be trying to figure out, why is that right? It sounds wrong.
Throwing out random answers.
Exactly. Nice job. But then dang it, I am. I wouldn't do that. I've never done that before. Okay.
Where are they?
That's a good question. Oh, okay. We're good.
Yeah, me and Miles will be on tomorrow.
Yes. Oh, that's right. You're going to South Omaha. Yep. No, we were talking about you guys earlier today. That's what I'm laughing at.
Who was?
Anyway, so let's take a look at this. I just had some people hoping that our males behaved.
Where?
At South Omaha.
All right, maybe I don't want to get jumped.
It's
Hey, what?
you guys.
Yeah.
Okay.
Buddy.
Okay. On these, I want you to multiply these out as well, please. Okay? Just to show me that you can.
No, I think he's. No, it probably was then too. God forbid, I don't want to get 7 years ago.
I like how you guys are talking about South O like it's a really dangerous place.
It is.
You're letting your minds run away with you. Okay. I'm going to do 1 and 3. Let's do 19 through 25 odd. Okay. Okay. If you guys use your time, I'll just leave it at that, and I won't add anything to it. But
Will you record tomorrow? He's got to watch the recording.
yes, yep, I'll watch it. Yep.